And how is your day?
Was good.
Okay.
Like a bit long day, but it was good.
Okay, okay. Okay, so today we will see seismic design first.
Okay.
Okay. So for that, I am going to open a new project and I am going to select space and I'm going to name it as seismic one like that. And then length unit, I'm choosing meter and force unit, I'm choosing kilonewton. And then next, and I'm going to use open structure wizard and I'm going to finish it. And here I am going to use frame model. Just going to put this bay frame and I'm going to have the same length, height and width. I'm just going to put apply and then I'm going to close it. So it will ask the origin. Okay. And after immediately we need to do support. I'm going to create a fixed support. Select the support first and then go to the front view and then select it, assign to selected nodes, you need to assign and double verify it whether it is okay in a 3D view, okay, isometric view. Yeah, we have find all the foundation. Now, next what we need to do, we need to go to assign property. And before property, better we have plates also here in this. Here we can have 4 noded plates. And I'm just going to put 4 noded plates here. And then I'm going to select the plate and I'm going to use translational repeat. And direction, I'm going to use 3 and 3 default spacing. Again, I'm going to select everything, translational repeat, Z direction, again 3, and again put 3, okay. Again, I'm selecting everything, translational repeat, in which direction it must be.
Should be on the Y.
Why? You are right. I'm going to put 4, and then
4 steps.
uh, okay, now you select like this and you can choose. Otherwise, you can check here also.
Yeah.
And I am going to assign property. Property, I'm going to assign a rectangle of 0.3 and 0.3 for column. And then I am going to use 0.4 and otherwise 0.5 and then point I think 0.23 or 0.3 also enough. Okay, I'm going to this as beam. So 2 I am assigning, and again I am going to use assign that slab thickness of 0.15. Now I'm going to assign this to our view. Like what I'm going to do means select beams parallel to y-axis and assign to select beam. Again select beam parallel to x. No, first we need to select the second one. Select beam parallel to x. Select beam parallel to x. Select beam parallel to z. Now you can assign to select beam. Now in like this. See, we have a beam and then we have a column. Okay, now I'm going to assign plate thickness also to our elements. No, I'm going to put assign to view. Assign to view S. Now we also put plate thickness. So this is our structure. This we are going to analysis for seismic.
Okay.
Seismic in the sense, I think earthquake load. It is something like earthquake load. We are going to analysis for that seismic.
Okay.
Now I'm going for loads and definition. And for this, actually, we need to have definition first. Like wind load, we need wind definition. Like in seismic analysis, we need seismic definition. So some kind of analysis, we need definitions. Without definition, we can't able to proceed further. Okay, so I'm going for seismic definition, and I'm
Mhm.
just click add. And here I'm going to use Indian standard IS 1893 2002.
Mhm.
So you can choose any of that, but normally we use IS standards, and you can include accidental load or include IS that 1893 part 4.
Okay.
It depends on your thing. And I'm just going to select generate. When you're putting generate, it will give you the city and then the name of the cities. For example, Chennai. If you're selecting Chennai, the damping ratio, that things, zone factor, everything it will come.
Does this list like have all the cities in the world?
Yeah, it will be.
Okay.
But I'm going to select zone. Zone in the sense second point one only. Zone 3.16. This zonal factor only important. Zone 5, select if you want. Zonal factor of
Okay.
0.36 it is. And what I'm going to do means response reduction. Response reduction in the sense we have lots of options: ductile shear wall, load bearing, ordinary RCC. Normally they use special RC moment resisting frame, SMRF. Okay,
Okay.
it depends on your requirement. So I'm going to use the same special RC moment resisting frame. Okay, for that its value is 5. And even if you want to change, you can change it. Sometimes we can't change. Even this 5 also we can't change. It depends on the option that you choose. SMRF
Mhm.
option 5 only it is. And it is a general building. If you want to consider this as important building, you can put important building in the sense if it is a hospital or if it is like an institution, it is like important building where everyone work every day, like everyone will
Yeah,
need.
yeah, yeah.
So the factor of safety will be 1.5.
Mhm.
So it is general building, it is 1. Important building, factor of safety is 1.5.
Okay.
And then rock or soil type, hard soil, medium soil, soft soil. It depends on the soil condition that you have. Anyway, I'm going to use medium soil. And then structure type, RC frame structure. If it is a steel frame structure, you can select steel frame structure.
Okay.
Anything apart from this, you can choose all other buildings.
Okay.
Here we applied concrete only, so that's why I'm choosing reinforcement concrete, RC structure. And damping ratio, you can put 5 or you can put 10 percentage, whatever you want. And
Mhm.
foundation depth you need, you can put foundation depth. A foundation depth of 5. If you want to put a 12, you can put 12. And period, even period also you can modify. It depends on the calculation. These values, you need to study your code of practice, and you need to find the right formula, and you need to find the right numbers.
Mm.
Okay, in every code, like a code of practice, that book, the code book, you will be having lots of formula, and you need to input the values in that formula, and you need to find the final numbers. These numbers I'm not putting just like that. It came from that kind of calculations. Okay, you need to calculate these things, like this damping ratio and everything. Okay, but I'm putting just like that. You need to calculate and you need to input your values here. Now
Mhm.
I'm going to generate it. Just generate, and then I'm going to put add.
Okay.
Add is important. After adding sulfate, it will ask you put sulfate as it is. Joint weight, it will ask, you can put joint weights for the nodes. And then member weight concentrated or uniform. I'm going to put uniform of 2.5 kilonewton per meter. And it will take automatically, no need to specify the distances, add. And then element weight in the sense, like you can put a 3.75 like that. Like it is kind of a load that's going to add on the element on the slabs. And floor weight, you can put a floor weight of minus 2.5 kilonewton per meter square. And it is in the y range of where from here, this point to this point. Okay, so that I'm going to put 3, this one 3, and then this one 15. So minimum 3, maximum 15. And I'm going to add it. And after we got everything, now what I'm going to do means I'm just going to assign it.
Right. Yes.
Assign to view, assign to view. Okay. And after we need to go for load cases, important thing here is you need to add first seismic load. Don't add any other loads, otherwise it won't work at all. I'm going to add seismic load first and then close it, and then I'm going to add a seismic load here in X or Y direction, X or Z direction. I'm going to use X direction alone, and I'm going to add it. Yeah, now we got it. Now we can go for adding dead load. So this is important. And after you can add live load also. And I'm going to add a dead load of self weight, live load of member load. I'm going to add, even pro load you can add. Okay, I think the member load I'm going to add 1.5 kilonewton, otherwise 2.75 kilonewton per meter. I think minus could be better. Okay. Now I'm going to assign to view this one, and this one also I'm going to select. First select beam parallel to X, select beam parallel to Z, and then assign to selected beam. Now we got it. We assigned a member load also. Okay.
Why didn't you put it on assign to view?
No. If you are putting assign to view, it will be going to column also. That is like not needed. Like this member load going to act on these four corners, four edges. Otherwise, it will be like loads also come here also. It should not be like that. I am going to use only member load for the horizontal member, not the vertical member.
Okay.
In that case, you need to select like that. Okay, now we did everything. Now I am going for analysis and print. Now I am going to put all, add, and then close. Now I am going to analysis it. And we should not get zero, we should not get any error or any warning or any, these things okay, but we should not get any error.
Okay.
Zero error, one warning, one note, that's fine. And I'm going for output file. And here it is like a note. What note it is? Please note that depending on the shape of the floor, you may have to break up the floor or one-way load into multiple commands. So it is telling something regarding floor. It is asking to use one-way or two-way load, something like that. That is fine. Warning. Warning, it is telling UBC analysis as tension or compression. So these things fine, but still, if you can able to reduce or rectify these things also, it will be even more fine. The results will be even more accurate. Okay, you need to change some values in the inputs will go. Even this warning will go if you change the inputs.
Mm.
And result, applied load, everything, it came as usual. I'm just closing it. Now I can go for post processing and I can go for anything. So this is what the seismic analysis. So whether it is okay for it to pet or everything like that. If it is a even more skyscrapers, it will be even more fine, so that it will give you the fine solution.
Mm.
Now we can go for concrete design. As I said, just go for a concrete design. IS 456 and select parameters. Compressive strength I am taking, and then depth. These two I am taking. FI main, FI secondary, maximum main, maximum secondary. Okay, this thing's okay, I think, and I'm going to define it. And I'm going to put a 0.6 here, depth, FC, like I'm going to put a 25,000. Four one five triple zero. 415000. Maximum main, we can choose any of this. Maximum, I'm going to choose it, 25, and I'm going to add. Maximum secondary, I'm going to choose 12. Okay. Now I'm going to assign to view. And then you can go for commands. Commands, design beam, I'm going to add. Design column, I'm going to add. Design slab, and again take off for quantity. And then assign to view, and assign to view, and assign to view. Now everything we done. Now again going for analysis and print. I'm going to choose all, add and close. Now I'm going to analysis again. Now this is for concrete design. After seismic analysis, we must do concrete design, and we can go for output or go to post processing mode directly. And now you can go for beam and then select beams. Now if you are getting concrete design here, your structure passed. Otherwise, your structure fails. If you're not if you're not getting concrete design here, that your structure failed, you need to reanalysis. Now I'm getting, see, it is like showing 16 bar, 16 bar, number 8 numbers of 16 bar we need to have in this kind of beams. And even we can go for columns. The column, it is telling 8 number of 16 bar. Depends on the load factors that we are inputting.
Yeah.
Okay, you can able to just even sometimes some beams it will change also. Even you can change here. Actually, I applied the same load, so that's why here it is 16. If you are considering only from here to here floor load and not for this one you can consider roof live load. That one, if you are reducing the kilonewton, here it will automatically show you only 12 or something less than this bar. It depends on the load actually. Now you can change, you can check for the deflection also for the seismic load, date load, or live load in y direction, z direction. These things like shear bending,
Yeah.
everything, these values. Yeah. Important is concrete design, so we can able to see this reinforcements. Yeah.
Okay.
So this is what seismic analysis. Now you can do the same for any kind of structure, even for the steel structure also.
Yes.
Okay.
Mm-hmm.
Okay. Some of the factors here important, like seismic definition you need to add. That is important. Without seismic definitions, without that, we can't able to do seismic analysis. And the second thing, you need to add first load factor as seismic, and then you can add dead load, live loads. So otherwise, if you are getting error because of this only. Okay.
Okay.
Okay. If you're following the same procedure, you won't get any error.
Mm-hmm.
Okay. Now, if you want to try your own structure, then you can try and
Okay.
share your screen.
Okay.